Hi everyone, and welcome to the second of two videos going through some past paper questions on the topic of electronegativity and polar molecules. This first question here is asking us about sulfur hexafluoride. So it's a non-polar covalent molecule and it has an octahedral shape. That's something that we should know anyway. This is the classic example of something that's octahedral. So we need to explain why it has an octahedral shape. You can see that these, if you watch the other video on electronegativity, you see that the questions on this topic very much rely on knowledge of the shapes of molecules topic. Okay, so it usually starts off with something like this. So why is it going to be octahedral? Okay, well, the shape of the molecule always depends on what electron pairs we've got. Okay, and it always depends on the central atom. Okay, so we're going to say here the sulfur atom has 6 bonded pairs of electrons. And why do the electron pairs matter? Because the electron pairs repel each other. Okay, and in this case, they're all going to repel each other equally. We've got no lone pairs that are going to change the bond angle. So it has 6 bonded pairs of electrons which repel each other equally. It then says fluorine has a higher electronegativity than sulfur. Okay, we saw in the previous video that fluorine is the most electronegative element, so that makes sense. So there is a dipole. Fluorine has a higher electronegativity, and yet the SF6 molecules are non-polar. Explain what is meant by the term electronegativity and suggest why they're going to be non-polar. Okay, so we've got two things to do here. What do we mean by electronegativity? So electronegativity, we saw this in the previous video, okay, but you can see this definition does come up quite a bit, so it's worth making sure that you know it, is the ability of an atom to attract a pair of electrons in a covalent bond. Okay, make sure you put that bit on the end. Okay, it's not just attracting a pair of electrons out of the ether. It's electrons that are already being shared in a covalent bond, but they're being shared unequally because they're more attracted to one atom than the other. So it's the ability of an atom to attract a pair of electrons in a covalent bond. Okay, so why is the SF6 molecule non-polar? Okay, we spoke about this in the previous video as well. There is a standard answer that they will want you to write. Okay, the SF6 molecule is non-polar. It could be because there is no difference in electronegativity. Okay, that would make it non-polar, but that's not the case because they've told us there is a difference in electronegativity. So if there is a difference in electronegativity, it must be that the dipoles within the molecule are cancelling each other out. Okay, so the SF6 molecule is non-polar because the dipoles in the molecule cancel out. And if the dipoles in the molecule are cancelling out, it must be because the molecule is symmetrical. Okay, these things always go together. Symmetrical means the dipoles cancel out because they're pointing in opposite directions. If it's not symmetrical, the dipoles do not cancel out. Okay, then it's now asking us about nitrogen fluoride instead of sulfur hexafluoride. It has got a permanent dipole in it. Explain why it's got a permanent dipole. Well, this goes back to the same idea we were saying. Fluorine is the most electronegative element. So you can put fluorine in a molecule with anything and it's going to have a polar bond. Okay? So the first bit is it has a polar bond because fluorine is more electronegative than nitrogen. It's always good to say which way round it is. Rather than just saying there is a difference in electronegativity, you can show off a bit of extra knowledge by showing that you know which way it's going to be. Nitrogen itself is quite electronegative, but it's not as electronegative as fluorine, obviously. So it has polar bonds in it, but then why does it have a permanent dipole? Okay, well, if it is a polar molecule, it's going to be the exact opposite of what we've written here. Okay, so we said SF6 is non-polar because the dipoles cancel out because it's symmetrical. Okay, so here we can say NF3 is a polar molecule, and it's just the exact opposite answer because the dipoles don't cancel out. And if the dipoles don't cancel out, it must be because the molecule's not symmetrical. Right, just a couple more questions I want to have a look at. And you'll see how repetitive these questions are. We've now got BF3, so here's yet another different atom with fluorine. We've had sulfur bonding to fluorine, we've had nitrogen bonding to fluorine, now we've got boron bonding to fluorine. It's got polar bonds in it. As we said, if you put fluorine with anything, it will have a polar bond because fluorine is the most electronegative element. But the molecule is non-polar. Why is this? Okay, so why does it have polar bonds in the first place? So BF3 has polar bonds because fluorine is more electronegative than boron. The molecules are non-polar. Well, if it's got polar bonds, but the molecule itself is non-polar, it must be because, same answer again, the dipoles must be cancelling out. And why do the dipoles cancel out? Because the molecule is symmetrical. It is literally the same answer anytime you get this question. Well, it's either this answer or the opposite, depending on whether it's polar or non-polar. But how you structure your answer is going to be the same. So dipoles cancel out because the molecule is symmetrical. Just make sure you get this the right way round. It's very common. I see it a lot with people writing the dipoles cancel out because it's not symmetrical. So just be really careful. Okay, finally, here we've got some electronegativity values in a table. We can see fluorine is given a value of 4. That is the highest value. Everything else is less than that. And it just wants to use these values to put the dipoles on. So it's a nice, easy question here, really. We can see fluorine is more electronegative than nitrogen. So fluorine's going to be delta minus, and the nitrogen's going to be delta plus. The fluorine's going to be better at attracting electrons towards itself. Okay, remember, that is what electronegativity is all about. But I wanted to show this question because I've got a bit of a problem with this question. In the mark scheme, it's saying, well, look, nitrogen is more electronegative than bromine, so the nitrogen should be delta minus and the bromine should be delta plus. However, there's a very small difference between them. Okay, we usually would say that you need to have a difference of at least 0.5 in the values for it to be significant, okay, for it to really have a polar bond. So the mark scheme, as I said, suggests that this should be delta minus and this should be delta plus, but I think it's actually more appropriate to not put dipoles on it because there isn't a significant enough difference in electronegativity. Okay, this is an old question. I would hope that the exam board has learned from this one, because I'm sure there were some complaints when this question came out, and I think in the future they'd give you ones where it was more obvious, like this example, because you are opening yourself up to an argument about whether this is actually significant or not.